Section 5 and Section 6, solving. Well, number 1 of Section 5 is set up and ready to go. All of the terms have sign and it is in a quadratic form, meaning I have this term squared and then this term raised to the first power and then a constant. So let's go ahead and factor this as 2 sine x, leave some space, sine of x here. And I know I have to have a 1 and a 1 to multiply to give me 1 there. And then for my signs, I need a minus here and a plus here. And this is still equal to 0. So then I set each factor equal to 0. 2 sine x plus 1 equals 0. And the sine of x minus 1 equals 0. And then I solve each side separately. So over here, I have the sine of x equals negative 1/2. And here, I get the sine of x equals 1. To figure out what angle has a sine of negative 1/2, I look at my unit circle, and the angle that has a sine of negative 1/2, first of all, the negative means it has to be in quadrant 3 and quadrant 4. And the 1/2 means I need a reference angle of pi over 6. So the angle in quadrant 3 that has a reference angle of pi over 6 is 7 pi over 6. And the angle in quadrant 4 that has a reference angle of 1/6 is 11 pi over 6. So this is 7 pi over 6 and 11 pi over 6. For this part, what angle has a sine of 1? Well, there's only one angle that has a sine of positive 1 on this interval, and that is pi over 2. So my three answers here are pi over 2, 7 pi over 6, and 11 pi over 6. Number 2. I asked you during the test to change this, get rid of that 2. So let's just take that off. It's tempting to cancel the cotangent. We can't do that because remember when we cancel with a variable, we lose some of our solutions. So I'm going to bring this cotangent to the other side so that I get the cotangent of x times the cosine squared of x minus the cotangent of x equals 0. Okay. Then I can factor out a cotangent of x. So we've got cotangent x times the quantity cosine squared x minus 1 equals 0. And then it's just like this step here where I set each factor equals 0. So cotangent of x equals 0. And the cosine squared of x minus 1 equals 0. So over here, cotangent, remember, is cosine over sine. So this is the same as saying, where is the cosine of x equal to 0? So where on the interval from 0 to 2 pi is the cosine of x equal to 0? Well, it's equal to 0 at pi over 2 and at 3 pi over 2. Over here, solving, we get the cosine squared equals 1. Cosine squared of x equals 1. And then when we take the square root, remember we have two parts. We have the cosine of x equals positive 1 and the cosine of x equals negative 1. So again, where is the cosine of x equal to 1? That is at 0 on this interval. And then where is the cosine of x equal to negative 1? That is at pi. So we have four answers here. We have x equals pi over 2, 3 pi over 2, 0, and pi. That's the three answers. We have four answers. Okay, like I said, Section 5 or Section 6, number 1 is one that I did and sent to you on Thursday. So that's already a file on the website. So let's look at number 2 here. I see a sign of x on both sides. So let's combine those. 2 sine x plus the square root of 2 equals 0. Solving trig equations like this is the same process as solving equations when you first learned how to solve them in algebra. You want to collect like terms, you want to try to factor, set equal to 0, all of those types of approaches. Okay, so I'm down, and I have 1 sine x here, so I need to get this sine of x by itself. So I'm going to subtract square root of 2 and then divide by 2. So that I get the sine of x equals negative radical 2 over 2. Something going on crazy with my pen here. Negative radical 2 over 2. And now I'm ready to figure out what x is on the interval from 0 to 360. So from 0 to 360, where is the sign negative? Well, again, sign is negative in quadrants 3 and 4. And then I say, okay, radical 2 over 2. I need a reference angle then of 45 degrees. So the angle in quadrant 3 that has a reference angle of 45 degrees is 225 degrees. And the angle in quadrant 4 that has a reference angle of 45 is 315 degrees. Those are my solutions to number 2.